Hello everyone, I hope you all are doing well and welcome back to my YouTube channel. In our previous class, we discussed ray diagrams and ray rules for concave mirror. We also learned the four important ray rules and practiced different image formation cases.
Let's quickly revise those four ray rules. First ray rule, ray parallel to the principal axis after reflection passes through the focus. Okay. Second ray rule, a ray passing through the focus after reflection it becomes parallel to the principal axis. Third rule, a ray passing through the center of curvature reflects back along the same path without any deviation. Fourth rule, a ray striking the pole at an angle follows laws of reflection. That means angle of I is equal to angle R. Okay, students, in today's class, we are going to learn about convex mirror ray rules in a simple and easy way. Let's begin with the rules one by one. First rule, a ray parallel to the principal axis. After reflection, it appears to diverge from the principal focus in case of convex mirror. Okay, any ray of light traveling parallel to the principal axis, after reflection, what will happen? It appears to diverge from the focus from behind the mirror. Focus lies behind the mirror. Okay, so one more important point we need to understand here, the ray does not actually pass through the focus. In case of concave mirror, what will happen? The ray actually passes through the focus. In convex mirror, the ray does not actually passes through the focus. It only appears to come from the focus because the image is virtual. In convex mirror always produces virtual image. Okay, I hope you understand first rule. Second rule, ray of light traveling towards the focus. A ray of light traveling towards the focus, which is behind the mirror. After reflection, it becomes parallel to the principal axis. I'll repeat one more time. A ray which is directed towards the principal focus of convex mirror, after reflection, will emerge parallel to the principal axis. It will become parallel to the principal axis. Okay, this is the opposite of first rule. Okay, next. Third rule, a ray directed towards the center of curvature. After reflection, it comes back along the same path without any deviation because it strikes the mirror normally, means perpendicularly. So this rule is similar to third rule of concave mirror. Okay. Next, fourth rule. Ray incident at the pole of the mirror reflects according to the laws of reflection. Okay. So ray incident obliquely to the principal axis towards the point pole, the midpoint of the mirror is pole. What will happen? It follows the laws of reflection. That means angle of incidence is equal to angle of reflection. These are the four rules we are using to draw ray diagrams easily. Okay. In a convex mirror, we mainly use only two ray diagrams. And now let's understand the first ray diagram. First, always remember first rule. Okay. Any ray of light parallel to principal axis after reflection appears to come from the focus behind the mirror. Okay. Now, how do we draw it? Draw two rays parallel to the principal axis. One is above the axis, another one is below the axis. After reflection, what will happen? These rays diverge. Then extend these reflected rays backward. This backward extension will meet at focus. Where is the focus? It is behind the mirror. Okay, so this is a key idea. The reflected rays does not actually meet, but they appears to come from the focus forming a virtual image. So just remember first rule. So we are using first rule to draw first ray diagram. Okay, now let's understand the second ray diagram of convex mirror. In this diagram, we are using two rules, first rule and third rule. Okay, first recall first rule. A ray of light parallel to the principal axis after reflection appears to pass through the focus behind the mirror. Okay, third rule. A ray of light directed towards the center of curvature after reflection appears to pass back along the same path. Okay, so I hope you understand first rule and third rule. Now let's draw a ray diagram. First, we'll understand object position. We are keeping object between infinity and pole of the mirror. Okay, image will form between focus and pole behind the mirror. Okay, draw one parallel ray to the principal axis. After reflection, make it diverge and extend it backwards so that it appears to come from the focus. Next, you draw second ray towards the center of curvature. This ray will reflect back along the same path. Here you can use dotted line also for extension to represent extension rays. Okay, now extend the reflected rays backward. They will meet at a point behind the mirror. This point is where the image is formed. Okay, I hope you understand second ray diagram. We are using rule 1 and rule 3. Object position is between infinity and pole, that is anywhere in front of the mirror. Okay, infinity and pole is nothing but anywhere in front of the mirror. Mirror position is between focus and pole behind the mirror. Then what is the size of the image? Size of the image is diminished and nature is virtual and direct. Virtual and direct image will form between pole and focus behind the mirror. Alright students, I hope you understand the ray rules and ray diagrams of convex mirror. As we discussed, there are only 4 ray rules and 2 important ray diagrams in convex mirror. So practice them regularly. One more important point to remember, whenever you draw ray diagrams, you must always mark arrows. Okay. So because ray is not just a line, it's a line with a direction. If you draw diagram without arrows, then it is not a proper ray diagram. Okay, students, in the next class, we will discuss sign convention of spherical mirrors, including both concave and convex mirrors. After that, we will solve numericals based on spherical mirrors, which are very important for your exams. So make sure practicing ray diagrams. Thank you, everyone.